Electroplating is a process in which metal atoms are transported onto the surface of another metal using electricity. As a result of this process, the metal's surface is plated in a thin layer of the imported atoms. Electroplating is commonly used for decorative purposes and for preventing corrosion. For example, chromium is a metal which has high corrosion resistance and its appearance is aesthetically pleasing. So, chrome plating is used for decorative purposes, providing corrosion resistance and increasing surface hardness. Besides chromium, zinc is also used for providing corrosion resistance. The process of zinc electroplating is generally called galvanization. Zinc is plated onto steel or iron to prevent rusting. The zinc layer sacrifices itself and rusts over time, so the plated metal is protected, and this process is called sacrifice plating. Electroplating is carried out with a special device called an electrolytic cell. An electrolytic cell consists of a DC battery, electrodes, and an electrolytic solution. The electrode where atoms give electrons is called the anode. The electrode where atoms gain electrons is called the cathode. This means that oxidation reactions are carried out at the anode, whereas reduction reactions are carried out at the cathode. In electroplating, the anode should be positively charged and the cathode negatively charged. The metal to be used for plating must be connected to the anode, whereas the metal to be plated must be connected to the cathode. Also, the electrolytic solution must be a solution of a salt of the metal used for the anode. For example, if we want to plate a piece of iron with copper, copper must be connected to the anode and iron must be connected to the cathode. Also, the electrolytic solution must be a solution such as copper sulfate or copper chloride. Let's say we choose copper sulfate. There are positively and negatively charged ions called cations and anions in the electrolytic solution, and they are able to move freely. When the current is turned on, positively charged cations, copper ions in our example, move to the cathode, and negatively charged anions, sulfate ions, move to the anode. The copper ions have migrated to the cathode, gain electrons, and become neutral copper atoms. Metal atoms typically become solid when in their neutral form. Therefore, copper atoms which gain electrons become solid and build up on the cathode. On the anode, copper atoms lose electrons because of the current. Therefore, these atoms move to the cathode and become solid. This process continues during the presence of the current, so copper atoms create a thin layer on the cathode. As a result of this, the anode's mass decreases and the cathode is plated by copper.
We have current controller, main controller, and electroplating bus in this equipment. Firstly, we turn on the power of bus controller. Then turn on the pump and heater. In the summer, the room temperature is high enough, but in winter, make sure the best temperature reach to the set value. Turn on the light of the bus. Turn on the lid. Turn on the lid of electroplating bus. Before plating, please use surface profile to test the thickness of PR in order to decide whether to plate again after the first plating. First, we connect the sample to the cathode. The black wire connects to the cathode, and the red wire connects to the anode. Fix the sample with a clip. Ensure that the clamp is connected to the metal part of the sample. Dip the sample in the electrolyte. Ensure that the sample is fully immersed. Put the lid on. Close the door. Here is the method to determine the current value. Then turn on the power of the DC power supply. Press Display Limit button. First, we set the upper voltage limit to 0.8 volt. Then press Voltage Current button. Set the upper current limit to 0.001 ampere. Wait until it quits to main menu automatically. Press Output button to start electroplating process. Turn the knob to control the current value. After a predetermined time, press Output button to stop electroplating process. Press Power button to turn off the controller. Then use Surface Profile to test the difference between PR and electroplating copper. The thickness of electroplating copper and electroplating rate can be calculated. You can decide whether to continue plating according to your own needs. Open the door. Open the lid. Take out the sample from the clip. Close the lid. Close the door. Turn off the light. Turn off the heater. Turn off the pump. Turn off the main power.